We're very lucky to have Jeff Engler with us tonight. One more round of applause for Jeff. That was excellent. So our second speaker is Blake Shaw. He also graduated from Columbia in 2005, and he is just now finishing up his PhD in computer science there, while at the same time he's been working at something called Sense Networks, which is a startup and doing amazing things there as well. And tonight he's going to be speaking to us about a topic he's been working on throughout his PhD, machine learning. And so without further ado, Blake Shaw.
Thanks a lot, Rob. So as you all know, I'm Blake, and today I'm going to be talking about machine learning, networks, and spatiotemporal data. Really, I'm going to be talking about the intersection of these three fields. So let's start with networks. Networks are systems of interconnections. It's people, places, things, interacting with each other, forming connections. Networks are built from nodes and links. These are the fundamental building blocks of a network. Lots of examples of networks. There's the nodes could be people, they could be websites, they could be neurons in the human brain. The links could be people poking each other on Facebook. It could be people text messaging each other. It could be websites linking to each other. Neurons sending electrical signals to each other. All these are examples of networks, and these are all actually really massive networks. On the right you see the number of nodes in this network. So Facebook has 500 million people. There's 250 million websites on the internet. There's 100 billion neurons in each of our brains, all with this complex pattern of interacting with each other. So networks are all around us. And actually for the first time, we're able to really capture and record these networks because of computers. All these networks represent this huge store of data. And finally we can record them and analyze them. But how? I mean, you know, Jeff's not going to sit there with an Excel spreadsheet open with 100 billion rows in it. Like, how do you get meaningful information out of this massive data? And the answer is machine learning. Algorithms that can ingest this massive data and figure out patterns, infer patterns from massive data sets. That's the sort of fundamental idea behind machine learning. So let's consider an example. All of you guys are familiar with Google, and there's an algorithm that made them famous, and it's called PageRank. It's a machine learning algorithm that has to do with networks. So Google wants to know which sites on the internet are important. They want to know which sites are authoritative. And so they want to be able to tell the difference between, say, the New York Times and Rob's blog from China. So they're actually found a way to do this without even reading any of the text on any of these sites. They're just going to look at the links between all these websites, and they're going to represent these links in a way that a computer can understand, this large binary matrix. Think back to high school math, matrices. If you basically, it's almost unintuitive that you could take just all these links, just all these random links, New York Times linking to Huffington Post, and Huffington Post linking to some other news website, and encode it in this, you know, binary matrix in this form where zeros represent not connection, 1 represents connection. And all you have to do is actually do some matrix multiplication on this thing inside a computer, and out pops out this authority value of every website on the internet. And it's amazing, right? You would never sort of think that, you know, given all these links on the internet, something so intelligent could emerge from such a system. But it did. And Google really, you know, cashed in on that quite well. So that's a good example of machine learning and networks. But now I'd like to talk about another source of data, spatiotemporal data. And I don't know, it might not be obvious, but there are 1 billion devices in the world right now that are constantly emitting this signal of latitudes, longitudes, and timestamps. And this is amazing. This is a network of people connecting with each other, connecting with places, and really this data is a lingua franca. It's a common language between all people. There's no, you know, language or countries or borders. This is like something that's standard, that's being generated by 1 billion people right now. And it's massive. This is on a larger scale than the internet. So the question is, can we do for spatiotemporal data what Google did for the link structure of the internet? Can we take advantage of this network of people and places to build intelligent services? And I'd like to say that we can. Let's consider this simple example. We want to know which bars in San Francisco are similar. So we can observe people running around San Francisco. We can identify the top 200 nightlife locations. And these locations, they form a network. And we can think about people flowing between all these places on this network. And then we can apply a machine learning algorithm to transform this network so that it's not existing in latitudes and longitudes anymore, but nodes or places are next to each other if they're similar. And this is the key to color coding this network, to figuring out which of these bars are actually similar, because people come from different places to go there and they leave to go to the same places afterwards. And so this allows us to really understand the people and the places that make up San Francisco and make up San Francisco nightlife. So we applied this analysis to New York City. And this is actually, the results are almost unimpressive, right? You can see that what we've done is we've color-coded every single block in New York based on this notion of similarity. And this notion of similarity has nothing to do with boroughs or county lines or anything like that. But we see these natural neighborhoods emerge. And you can see that there's a clean distinction of the Upper West Side and downtown and East Village and West Village. But really all of this just sort of came out of the data. It all just emerged from understanding this network of places and people. And so, in conclusion, we should all throw away our cell phones immediately. Just kidding. In conclusion, mobile phones are producing just massive amounts of data. And coupled with the fact that we have these new tools, these machine learning algorithms, for actually finally understanding and making sense of this data, you can expect to see so many new services, intelligent services that'll use this. Today it might be Google's PageRank or Netflix's movie recommendation algorithm, but tomorrow it's going to be an algorithm that really understands human behavior and how we interact with each other and the world. Thanks.
Yeah.